the last section for prepping for pre-calc. This is the second part to go along with notes for P7. I like this last little part and I like to go over it because a lot of times on standardized tests they give you these projectile motion problems, and once you know what everything means, it's very easy to figure stuff out. Also, your graphing calculator is an excellent way to solve inequalities. So let's start out by solving this inequality using our graphing calculator. The steps are listed there on your pre-printed notes, and the first step is to get 0 on one side of the inequality. So we're going to subtract 12 from each side to give us 5x squared minus 11x minus 12 greater than or equal to 0. Remember, this means positive, so it's going to be bigger than 0. It's going to be on the positive side, or the y-axis, up and down you're looking. Second, you're going to find the zeros. Those are our boundary points and critical points for our graph. So when we solve this, it will factor to 5x plus 4 times x minus 3 equals 0. If you don't know how to factor, remember that quadratic formula always works. When we set each of the factors equal to 0, we get y equals negative 4/5 or y equals 3. Now we're going to pop it into our graphing calculator. So we're going to graph it, and the graph looks like this, as you would expect. Now this looks like it's negative 5 to 5 by negative 5 to 5, y, x min, x max. And you can see it cross right here. That's negative 4/5, we know, because we just solved that. And this would be 3. So those are our critical points. That's where the graph crosses the x-axis. So what we have to do is we're going to actually look for the solution. Solution is the range where the graph is either above or below the x-axis. When I look at this graph, since it is greater than or equal to 0, we want the positive part. So we're going to go above the x-axis. So that's the part that would have positive y coordinates. So when we go to get our solution, the graph is positive all the way up here from 4/5 on and from 3. Get in your mind that those are the x intervals. So when I look from 3 all the way over on the x-axis, the graph is above the x-axis. It's positive results, a positive output. When a graph is from negative 4/5 on down on the x interval, the graph is also having a positive output. So that's how you can do your solution. So the solution for this would be from negative infinity to 4/5 square bracket union 3 to positive infinity, and that's it. So very quick with the graphing calculator as opposed with all the tables and things if you do it by the algebraic method. Projectile motion. They love to throw this on standardized tests, and it is a very simple equation if you know what everything means and the fact that they're going to give you some of these values. Something I want to bring up, when you see this little 0, that always means your initial something or other, or the start of something. So it says, suppose an object is launched vertically from a point s sub 0, that's initial height, above the ground, with initial velocity of v sub 0 in feet per second. When you're doing velocity, remember it always has to be a distance with time. So feet per second, miles per hour, all that. You don't say, hey, I was going really fast, I went 60 miles. Because that tells nobody what speed you went. So make sure that you remember velocity is something per unit of time. The vertical position s, so that's how the height of your object. T seconds, again, t is like our x. After it is launched is given by this equation, negative 16t squared plus v sub 0 times t plus s sub 0. The v sub 0 and the s sub 0, they're going to give you in these problems. So let's look at this first example. Remember, our projectile motion is this equation, s of t, that's the height at time t. T stands for time. V sub 0 is initial velocity, and it's always some unit of measure per time. And s sub 0 is your initial height, where you start from when you throw the ball, when you shoot the cannon, whatever. That's your initial height. Suppose a baseball is thrown straight up from the ground. Ground level, that's our first clue. That's going to go in for initial height. With an initial velocity of 80 feet per second, that's another clue. It's going to go in for v sub 0 into our equation. When will the baseball be at least 64 feet off the ground? At least 64 feet. So that means it's 64, 65, 66, and so on off the ground. So we're going to have an inequality. So when we look here, we're going to put that in for v sub 0, this in for your ground level because you're 0 feet above the ground. And this gives us our height at a certain time, but since it's at least, it's going to be an inequality. So when we do this inequality, we're going to replace, we put the 80 in for v sub 0, and it's going to be this height has got to be greater than or equal to 64. It's got to be bigger. We want to know when this is going to be larger than 64 feet. So when we plug this into our graphing calculator, I'm going to put that in for y1 and that in for y2. And I'm going to look to see when my graph is above 64. So when I draw it, here's what it looks like. There's my parabola, and then I have a straight line. This is y equals 64. So you can easily see that this part is when the graph is above 64 feet. That's when the height, which is given by our y1, is more than 64 feet. And you just have to find the interval. So when you look at the intersection, so remember, find the intersection, you'll get the intersection is 164 and 464. 1, if you recall, is your x value. That's your time. If you keep in mind what x stands for and what y stands for, it will make it so much easier. In this case, x is time and y is our height. So from 1 to 4 seconds, it's above 64 feet. So the solution is the height where it's above or equal to 64. It's above 64 feet from 1 to 4 seconds. So its t would be between 1 and 4 seconds. Or you could write it in interval notation with the square brackets. But that's how you solve it, and it's very simple in the graphing calculator. We can answer a lot of questions. How long will it be at least 64 feet above the ground? Well, since it's between 1 and 4 seconds, you just subtract them to get 3. Write an equation that could be used to find how long the ball is in the air. Well, that would be when the ball is above 0, when it's above 0 feet. So when you do this one, the height has to be greater than 0. So we'd have negative 16t squared plus 82 is greater than 0, and we would solve that one. How is more than 10 feet off the ground? Well, more than 10 feet would mean this height would have to be greater than 10. So that would be the height is greater than 10, and height is negative 16t squared plus 80t. It would have to be bigger than 10. If a baseball is thrown straight up with an initial velocity of 48 feet per second, what is the algebraic representation? Algebraic representation. Ooh, isn't that a nice long word? For the distance above the ground. So they're saying, what would the equation be? And if you look at this guy, the only thing that's going to change is the velocity, the initial velocity. Instead of being 80, it's 48 feet per second. So it's going to be s equals negative 16t squared plus 48t. It's thrown from the ground, so again the initial height is going to be 0, so we don't even have to add that on there. When it's above the ground would be greater than 0. So this would be your inequality for that. That would be the algebraic representation. When they say algebraic representation, they just want the letters in there. All right, that's it. I hope this helps with the projectile motion problem in your homework, and that you have a very good afternoon.